Thank you for coming here this morning. We're really glad that you made it here after yesterday's parties. We would like to welcome you on our talk on the very last day of the Black Hat Europe 2012. And today we're here with my colleague Dmitry Sklarov. My name is Andrei Belenko. We work for a company called Elcomsoft, which is based in Moscow, Russia. We mostly do the software development for computer forensics and password recovery tools. And today we would like to present you our research, which will analyze the security of password keepers, password manager applications on modern smartphones. So let's start. Today we will start with a short overview of authentication, how it's done on computers and how it's done on smartphones. We will then proceed to establish the threat model under which our research was made, to see what are the threats and how can we exploit them. After that, we will proceed to actual analysis of BlackBerry password manager applications and iOS password managers. And then we will present you some information to conclude, some summary information about our findings, so that you can have an idea of the state of security in this field. So let's talk about authentication. Well, on computers, on conventional computers like PC or desktop Macs, there are a number of options which are available for developers to use as a means of authentication. First of all, this is a trusted platform module, which is a secure piece of secure hardware which is installed in computers, well, in some of them. And what it basically does is it authenticates the hardware before performing some sensitive operations such as decryption. So if you just change the hardware, introduce some malicious part to it, it will not pass the authentication process. The second mean of authentication is something more traditional. It is biometrics. It is something you are. And again, on computers, it's fairly easy to buy a fingerprint reader or something like that and to integrate this into the authentication process. Well, we're not talking now about the reliability of this authentication. The point here is that it can be done on desktop computers with relative ease. The third way to perform authentication is a smart card plus PIN code. It is something you have and something you know, or as one of my friends says, something you know and something you usually leave at home. Well, again, smart card readers are cheap. There are products, solutions that can help you build a corporate environment for two-factor authentication. So it's possible to do this on the desktops. And the last, it's probably the still most popular one, and still the reason why our company has some business, is password and passphrase authentication. It's used everywhere, and I'm not sure if I need to talk about this in more detail. Well, on smartphones, the situation is very different. You don't really have a TPM or biometrics or smart cards on smartphones, because most of them are pretty restrictive in what you can do, what you can run, and what you can connect to them. And pretty much the only way of authentication that is left on the smartphone is PIN, password, or passphrase. Well, here I would like to just give a short note about the TPM. Well, technically speaking, most of the modern smartphones, they have some secure coprocessor inside of them, for example, iPhone. But the problem is that application developers cannot talk directly to this coprocessor. So the system can, the applications can't. And applications cannot use this secure piece of hardware to increase the protection level of protection. So essentially, there is no such thing in terms of from the point of view of software developers. So on smartphones, we're pretty much left with the passwords, passcodes, and this pattern log is actually, it looks different from the passcode, but essentially it is a numeric password. In this example, the corresponding password will be something like 1425698. Just the numbers which define the route you swipe the pattern. So the password is the only authentication, the only common and reliable way of performing authentication on smartphones, but there are problems associated with it. Well, the first problem is that typing passwords on smartphone is a pain. On PCs, on laptops, you have a full-size keyboard. You can utilize your motor memory. Well, I'm pretty much sure that everyone who's using a random or semi-random passwords, they cannot spell them if they're asked to take a pen and spell them, but you can type it in. So for example, with me, this is the case. I don't know my passwords, I mean how to spell them, but I know how to type them. Again, it's relatively easy to memorize using motor memory long and relatively complex passwords on the full-size keyboards. With smartphones, it's a completely different story. Touch screens, they do not give you the feedback, I mean the mechanical feedback to your fingers. So you really need to look where you type, and this complicates the process. This makes it more difficult to use long and especially random passwords. So it's okay to type a word, but again, how many errors do you make even when you're texting? So the spell checker always replaces the typos. Sometimes you don't notice them, but if you enter a password, the spell checker will not fix the password for you. So, and it's much more difficult to use long and complex passwords on the smartphones, especially on the smartphones with touch interfaces. On Blackberries with the small keyboards, it's somewhat easier because you still have some mechanical feedback. But again, it's much more difficult than on full-size keyboards. So we think and we believe that it is fair to assume that passwords on the smartphones will be shorter than their counterparts on the PCs. I mean, if used by the same person. Next problem is password cracking. Well, smartphones, let me explain this. The bad guys, the people who want to crack the password, they're usually smart guys, and they will utilize the most powerful platform they can find. I mean, if this is a password, if the passwords they want to crack, it protects some data on the smartphone, it doesn't mean that the attackers, the bad guys, will use the same smartphone to perform the actual cracking. They will offload the computation to more powerful processors, to CPUs, to GPUs, and so on. And this will increase their chances to crack the password. The problem here is that the passwords are usually used in a way that before there is some encryption usually involved which is based on a password, and the encryption key is computed from the password. And usually it is computed using some complex cryptographic transformation, like performing 1 million of hash iterations or something. And there is a problem when you try to do this on a slow platform like, for example, BlackBerry, because the CPU is slow, and you don't really want to create a program which will take 5 minutes to verify the correctness of the password. But really, the way to avoid this is to reduce the number of iterations to make this password to key transformation less complex. But at the same time, this will lead to faster password recovery attacks on the more powerful platforms like PC. So we have a challenge here. on one side, on the one hand, we need to reduce the complexity of this key computing function to make it usable and make interface responsive on the constrained platform like a smartphone. On the other hand, we need to make the password recovery slow on the fast platforms like PCs, like fast CPUs and GPUs. Well, today with things like iPhone, A4 chips and A5 chips, this is less of a problem, but a few years ago this was really, and especially with BlackBerries today, it's still a problem. And of course, I said the attackers are smart guys. They can always use GPUs or distributed computing to make password cracking even faster. And during today's presentation, you will see some indications of how fast GPU password recovery may be. So to some things about authentication, on the PCs, on the computers, you usually do not enter your complex long password too often. Usually when you start your working day, you log into your workstation, you continue working until break, then you lock your screen, go to lunch, return, unlock your screen, continue working, and so on. This is the typical, I think, we think this is the typical scenario. So it may be 5, maybe 10 times a day you need to enter the password on the PC. On the smartphones, it's a completely different story. You need to enter the PIN or passcode every time you want to make a call, to read a text, to send a text, to read an email, to send an email, and so on. So it makes it somewhat like forces people to use shorter passcodes, I would say. And at the same time, handling passwords on smartphone is more difficult than on PC for the reasons I have explained before, because you need to have a higher level of protection with fewer resources. So this is the problem. So now let's move to the threat model. Throughout the research, we assume that attacker has physical access to the device, or attacker can read the backup files of your device, or attacker can somehow else access the files that comprise the password manager database. We believe these are fair assumptions, and I will try to explain it in the next slide. And the objective of the attacker is essentially to get your passwords from your password manager database. So it may be like recovering the master password for your password keeper, or just decrypting the database itself. And I would like to point out that we will focus only at data at rest. We will not analyze the networking functions, the exploits in these password manager applications. We will solely analyze the data at rest, so how program handles encryption of the data stored on the device. So what about physical access? Well, there are a lot of computers stolen every year, and also there are a lot of phones stolen and left at the bars and so on. And since typical phone is much smaller than a typical laptop, again, it's much more probable that you will lose your phone than you will lose your laptop. So something like that. So now let's talk about device backups. Well, device backup, both iOS, both iPhone and BlackBerry platforms, they provide a user with the opportunity to create a device backups. Device backup contains a lot of sensitive information, like apart from passwords and databases of password keepers. Typical backup contains information about email accounts, texts, call logs, pictures, whatever, application data, a lot of sensitive stuff. And this is the reason why both platforms, they have some protections to guard your backups. On Apple iOS, first of all, to be able to create a backup, you need your phone to be unlocked. This can be done either by entering a passcode on the phone, or if your phone is already paired with the computer on which you're trying to create a backup. Also, there is an optional encryption of the backup, and on the iOS platform it is done in a, well, we think in a proper way, because the encryption is enforced by the device. So once you configure your device to produce encrypted backups, it will always encrypt backup before sending it to the computer. And to disable this encryption, you will need to specify the original backup password which you have entered. And this backup password, it is only asked from you when you try to restore from the backup, not when you create a backup. And this actually creates a usability problem for many users. For example, when half a year ago iOS 5 was released, it was initially released in a version where you cannot update the iOS. You need to do a device restore. So essentially everything is wiped from the device, wiped out, and then iTunes restores your last backup on the freshly installed iOS 5. And this created the problems because many users, it turns out, had a backup encryption switched on at some point in the past, but since they are not asked for the password, they just don't remember it. And there was a lot of people sending emails like iTunes has a bug, it's switched on the encryption on itself, I have never specified the password, and so on. And when you ask people questions, it turns out that the password is 1234, or the name of their cat, or the name of the neighbors, and we have a difficult time explaining to them why iTunes knows the name of their cat. But still, on the BlackBerry platform, the backup encryption is pretty much the same in terms that you still need the device password for BlackBerry to be able to create a backup. It is not possible to pair a BlackBerry with a PC, so you need to enter it every time you create a backup. There is also an optional encryption of the backup, but it's done in a somewhat strange way. It is not enforced by the device, it is performed by the desktop application. So if you have a BlackBerry device and you know the password, the backup encryption will not be a problem for you, because you can just bypass it, instruct the desktop application not to encrypt anything. But still, if you only have the encrypted backup, then you need to recover the password, and this can be, well, quite difficult because there is a really slow transformation involved. The next thing is, it is still, even if you don't have the backup, but you have the device, there are some scenarios where you may be able to obtain the required files from the device itself. So on iOS platform, this is possible through 3 different ways. First of all, you can use the AFC protocol, which is the protocol which iTunes talks to the device when it syncs application and all these kind of things. So there are programs that can access the application sandboxes on the phone and transfer files between phone and your PC. So it's possible if you can pair your phone with the computer, you can copy files between your phone and between your computer and certain application folders. Well, of course, jailbreaking, we still believe this is a bad thing because it reduces the security. So if you have a jailbroken phone and there is an SSH server running, you can access pretty much every file on the device remotely. So it's also possible to obtain files this way. It's also possible to get required files through the mobile forensics way of doing things, which is called physical imaging, when you obtain the bit by bit to bit image of the iPhone disks. So again, you can decrypt that and get required files. Well, on the BlackBerry, it's more difficult because, again, there are solutions to perform physical imaging of BlackBerries, but they all require device password. So on BlackBerry platform, it's really up to device password, whether you know it or not. On Apple iOS, there are different scenarios. So enough for the background. Let's do the actual application reviews. So let's start with BlackBerry. We will consider three applications. The first is BlackBerry Password Keeper. It was included with the OS 5, I believe. And the second application is BlackBerry Wallet. So BlackBerry Password Keeper, well, you can see, if you know a little about password cracking, you probably know that 3 iterations of PBKDF is not much, and that the password recovery will be very, very fast. In this case, we have 3 iterations of password-based key derivation function with the SHA-1 hash. And the data inside the database encrypted. It's okay. So if you just have the file, you cannot read the stored passwords in plain text, but still you can mount the password recovery attack. The password recovery attack will be very, very fast. It's about 5 million passwords per second on a modern CPU and up to 20 on the GPUs. And again, there is one thing which is quite interesting, which we can exploit in many different password keeper applications, and this is actually the PKCS7 data padding. So what is this about? Well, when you encrypt data using the block cipher, you can only encrypt data in chunks, and the size of the chunk is the size of the block of this cipher. For most modern ciphers, the blocks is 16 bytes, and the data, it must be padded before encryption. So, and also it must be padded in a way which will allow to remove the padding after decryption. So you need to somehow store the length of the original data, either explicitly or implicitly. So there is a standard for this, which is the PKCS7. Well, part of standard defines the padding. The standard says that you need to add to your plain text data certain number of bytes, so that the length of your data plus the length of the padding will fit evenly in the block of the cipher. So all blocks will be completely filled. And the value of the byte which gets appended to the data is equal to the number of bytes that get appended. So you can see on the screen, in the first example, we have the gray area is the plain text data, which we want to encrypt. And number 7, for example, in the first line, are the bytes. Each byte has a value of 7, and we have 7 of them. So this is how it works. Now, there is one special case when our plain text is completely filled with when our plain text already fits evenly in the block size. In this case, we just add an additional block completely consisting of padding. This is the last example. What this allows us to do is to quickly reject wrong keys. So when we're trying different keys and performing decryption, we can look on the last. We can actually decrypt only the last block and check if the padding is correct. So in the worst case scenario, this will give us, if there is only 1 byte of padding, this will give us a rejection rate of about 1. Well, the survival rate of keys of about 1 key in 256, which is actually very good. This padding, essentially it provides some sort of known plain text attack, limited but still. And the great thing is that it allows to gain better password recovery rates. And this trick is used for many different applications in our research. So, any questions about this? Okay. BlackBerry Wallet. This is the second application from BlackBerry. There are 2 versions. Version 1.0 was used with OS 5. It was not included with the operating system, but it was a free download from the app world, I guess. So this one is pretty straightforward. It stores the double hash of password. Password verification is very fast. 6 million on CPU and about 300 million on GPU. This is well, very fast, and I'm not sure why Research in Motion did this. Again, there is no randomness, no salt involved, so you can, if you really want to do this fast, you can always build the rainbow tables for this particular type and recover passwords in minutes and seconds. Version 1.2 was a little different. It's better, definitely. It's much better than 1.0, but still it's not good enough, in our opinion. It took an approach more like Password Keeper. So it is using the PBKey-DF2 with a random number of iterations between 50 and 100. I'm not sure about why it's still using that amount of iterations, but still it's much better than 3. And the speed, you can see the estimated recovery speed is 200,000 on CPU and about 3 million on GPU. Again, by today's standard, this is very, very fast. So just to give you an idea, like password recovery for password cracking for Microsoft Office 2007 documents is like, how much? It's like about 1 to maybe 5,000 of passwords per second. So it's nowhere near millions. And here we have, again, devices with a small keyboard where you cannot really type a complex passphrase, and the recovery speeds of millions passwords per second. So this is all about BlackBerry. I would like to give the stage to Dmitry, who will provide you more information about the iOS password managers and the security mechanisms, very interesting, which we found in them. Thank you.
Thank you, Andrei. Actually, there are a lot of applications available for people in the App Store, and we start from free one. We just type search in App Store Password Keeper, find a lot of results. Actually, there are hundreds of them, and choose several applications that claimed to be free password keepers or something close to password keeper. So there is a short list of that applications, and we will discuss each of them a little bit more close. The first set is actually not one application, but 3 of them. I call them unsafe triplets. They like triplets because they are actually the same application, but with different name, different icon, and different background. All else inside that 3 are absolutely identical, and it's actually very easy to find that data stored on SQLite database. All 3 applications use the same file name for the database. Master password is only digits 1, and the number of digits is 4. You can't set longer password, but actually it doesn't help you anyway, because nothing is encrypted with these applications, and it's just stored in plain text in SQLite database, so you could extract the password, master password, by one simple query to the database, and you could return back to the slogan of that application. It's really, really secure, as you see. But that 3 applications are not alone in App Store. So the next one, iSecure Lite. Again, it's not encrypted anything. You could again see the file name. It looks like some template name or some name from the code sample. So people just don't invest a lot of efforts to make application unique. They just slightly modify it and put on App Store. So actually many people downloading them. It's from the first one of results. So again, all information could be extracted by just direct query to the database. Next application is not positioned as password keeper, but it's some program to manage access control to some files stored on iOS device. And again, all data on plain text, no encryption, and very easy extractable. The next one is free companion application for paid one, but the author of that application, he honestly notes the difference between paid and free version. Free version doesn't protect your data. So it's password keeper that doesn't protect your data because it's free. I'm not sure that someone actually needs password keeper without protection. The next one of my favorites is my eyes only secure password manager. Again, it's promised a lot of benefits for user. It's use an ASCII archiver format common for Apple solutions for macOS and for iOS. And it's encrypt all secrets with RSA encryption, asymmetric. It's like standard for good security. It sounds impressive. And it stores private and public key and master password in keychain. Actually, storing some secrets in keychain is a very good idea for iOS because keychain items are protected by operating system and there is no easy way to extract all data. There are other ways, but they're not so easy as for applications that I discussed a little bit earlier. So probably using RSA and storing secrets in keychain is a sign of good solution, of good applications. But finally, it happens that the length of the key is only 512 bits. By the way, the first time RSA encryption of such lengths, RSA key was factored in 1999. So it's 13 years ago. At that time, it takes a lot of computation power, but now it could be solved in a couple of days on modern computers. And the most funny about using RSA is that private RSA key is stored inside the data file along with protected data. So secret is stored near the key. I don't know who invented this, but it looks very funny for me. Next application, keeper and password data vault. Again, military-grade encryption. It's really strong. This application uses MD5 hash to validate the password, and hash value is stored inside the database, and could be easily extracted from the database. And use SHA-1 hash, trimmed to 16 bytes as encryption key for IS algorithms. MD5, actually, it's format to be commonly used hash function, but it's not too good because there is collision built for MD5 many years ago. But MD5, it's like a platform for testing skills on GPU acceleration. Many people try to compete each other by implementing very fast way of cracking MD5 using GPU. Also, there are a lot of rainbow tables already built and available for free for downloading on the internet that allows you to find the password by its MD5 hash in a minute. The most easy way to attack such hash is just type hexadecimal value of your hash in Google, and in many cases you will find the password in a fraction of the second. So it's lightning fast to cracking such type of protection. So military-grade encryption doesn't help in this case. Next application, password safe, free version. It's have paid companion. We didn't test it, but I believe that security is almost the same. This is one application of all we analyzed that trying to prevent usage of easy guessable passwords. So that set of passwords, just check it, and when user try to set one of them, application notices him that this password is very easy to brute force by fingers, so it's better not to use it, and doesn't allow to set this password for protecting passwords database. But actually, encryption performed in a very funny way. We have password that just padded to length of 32 bytes to 256 bits and use it as AES key. And that key use it to decrypt master password, master key. That after that use it to protect all data. There is some string for validation, encrypted string present inside the database, but actually this application uses padding PKCS7 again. So after decrypting the key, you should have last block completely fill it with value 16, because IIS using block size of 16 bytes and key is 32 bytes. It's 2 blocks, and additional block is added, so we just don't need to decrypt the key to verify the password. We need to decrypt only last block and check its value. If all bytes are with value 16, so we find the correct one. So attacking this type of protection requires only one AES encryption, setting the password and decrypting one block. So it's really fast. And in many slides, you could see that on GPU we have speed about 20 millions. It's because for now we don't have optimized implementation of IIS encryption for GPU, and probably if we will spend some efforts to doing so, as we did for example, for MD5 and for PBKDF key derivation function, the rate of password testing will be increased in 10 or 20 times. And again, this application not used any randomness to generate encryption key from the password. So it is possible to build rainbow table and use it to attacking the data with a very fast rate. The next application, Strip Light Password Manager, again free and paid version, difference in amount of passwords that could be stored. And to be honest, this one is the best one from all passwords managers we test during our research. It's straightforward, simple. It's just use PBKDF with 4,000 iteration. It's very close to number of iteration used by WPA authentication on wireless network. So you could just look on the internet for speed testing for WPA, and you will get the same speed for this application. This application little bit easy crackable than WPA, but honestly, 4,000 it's good decision for mobile device. It's much better than most of other solutions. And by the way, this application uses slightly different way. It's not protecting records inside the database, it's protect the database in whole. So the whole database is encrypted, and open source component developed by the same company, by Zetetic. This company is available at source level, so we could analyze it and find the number of iteration and the algorithms. So we are finished with free password application, but it's actually it's good idea to think that paid application should be better than free one. They should protect data, because you could see that maybe except the last one, all others are not very good in data protection. So we just look in Google for good reviews about password keepers for iOS devices. We find several of them, summarize results of them, of that reviews, and choose 6 very popular password keeper for iOS, for iPhone, and start testing how they protect the data. One of applications, Safe Wallet, it's actually have version for many platforms, for desktop, for mobile platforms. Unlike most of others, it's use its own proprietary database file format that is common for all platforms. So you not transfer your data, you just copy the file from one platform to another and still have access to all your passwords. Inside this application, master key is encrypted with master password you provide when trying to open this application. Password is derived by PBKDF function with 10 iterations. 10, again, it's very little amount. It's better than 1, it's even better than 3, but it's still too little. So testing speed is pretty fast for GPU and for CPU. Next one is Data Vault Password Manager, actually a very popular one. It's use keychain for storing all secrets. So all protected passwords are encrypted using key and then stored in keychain using protection implemented by operating system. So it's a good idea to store anything in keychain, and for password validation, it's SHA 2056 bits hash stored inside the keychain. Keychain is not easy accessible, so to get hash value, you manage to bypass some security measures from operating system, from iOS. So if you have passcode protection on your iOS device, so you need to find that passcode before you will be able to extract data. But I don't know why, but authors of that application store that hash value not in data field of keychain item. Data field always encrypted. It's the main item of keychain record that should be protected. But on iOS 4, all other attributes still stored in plain text. So if you have iOS 4 on your device, SHA 2056 bits hash of your password will be stored in plain text. So you don't need to have passcode to extract that value. So it's, again, wide, broad way for attack. But in iOS 5, Apple helps developer protect their data, helps users protect their data, and start encrypting not only data field, but all other fields too. But to implement search capability for keychain items, iOS 4 stores hash of plain text value near encrypted value for every attribute. So for now, we have password hash encrypted and SHA-1 hash of password hash stored in plain text inside keychain. So again, we don't need to find the passcode. We could just add one additional SHA-1 computation to start our attack. So using keychain is a good idea, but it's used improperly. So attack is very fast, again, no randomness, and it is easy to build rainbow tables for attacking such application. Next one, MSecure. Again, very popular password manager, all data encrypted with blowfish algorithms. There is no complex computation, fixed key stored for validation, so fixed string. So you just need to decrypt it and compare with that original value. So attack requires only one hash and one blowfish calculation. Again, we don't have blowfish optimized for GPU, so attack speed is relatively slow, but if spend some time for GPU optimization, probably it will be increased a lot. Next application, LastPass, it's kind of services. So you will get application for free, but to use it, you need to subscribe for LastPass service that stores your information somewhere in the internet. And it's accessible from any of your devices. And after synchronization, after logging in inside this system, you will get local copy on your device. Its use master key derived as hash of username and password, and again, all implementation is very simple, no multiple iterations, so attack speed is very fast, and no good protection provided by this application. Next one. Actually, probably the #1 of password keeper on the market, 1Password Pro. There are a lot of other platforms that's supported by this application, and it's really popular. One of my colleagues used this one before we started this research, so it's really popular. This application allows you to use two different types of protection for different classes of data. So less significant data protected with PIN, which is usually shorter, and the most significant secrets protected with password of any complexity. All data are encrypted with advanced encryption standard, so even 128 bits is enough, in my opinion. And key is derived from PIN or password using algorithms that are represented at the top of the slide. You could see that there are many steps of computation that are necessary to correctly validate the key. So you need to calculate key encryption key as MD5 hash function. You need to calculate initialization vector as another calculation of MD5. You need to decrypt database key, then you need to decrypt validator using that database key, and then make comparison. But actually, you don't need initialization vector because you don't need to decrypt first block. Thanks to PKCS7 padding, you need to decrypt only last one, and initialization vector for last block is ciphertext of previous block. So you could just remove this operation from password cracking procedure. And actually, you don't have to decrypt validator because, again, PKCS padding allows you to reject wrong keys after decrypting the database key. So you could simplify these algorithms by factor of 2 just by removing unnecessary operations. So again, very fast cracking speed and not very good protection. And the last application in our review is Splash ID. It's maybe number 2 or 3 by the rate of many reviews. So there are a lot of people using it all around the world. Again, versions for different operating system. We looked only on version for iOS. So I don't know what's exactly how protection exactly implemented in other implementation in other version of that application. But on iOS, all data stored in SQLite database, protected with Blowfish. We already encountered it a little bit earlier, so it's not very fast in cracking due to absence of GPU optimization, but it's not pretty bad. It's just not very good. And master key is used as Blowfish key. Blowfish key could have arbitrary lengths. It's not fixed in length. And by some idea, I don't know why, master password is stored in database encrypted by some key. It could be called random key by definition of XKCD. So this time, random key, you could see it's really random. It's not easy guessable word, but it's hard coded in application. So every user of Splash ID, say for iPhone, have its master password encrypted using fixed key, so you could, in a second, extract your data from database, decrypt record with fixed key, and obtain master password. And then using that master password, you are able to decrypt everything else on this database. So 500,000 people using such protection, they just don't know about internals. And actually, it's very bad for industry because security that doesn't provide security is not a very good thing. And now I'm going to make some summary and conclusions. We mentioned iOS passcode many times during this presentation, and probably it's a really good example how passcode or password protection could work if you have actually, if you knew what you do. On iOS, starting from iOS 5, your passcode involved in protecting your secrets. So it's not just verified, it's used to generate so-called passcode key, and without that passcode key, it is impossible to decrypt many secrets stored within the device. Passcode derivation function is implemented using hardware IES encryption that embedded inside every example of iOS device, iPhone, iPad, iPod, and so on. And every device has its own unique key. So to calculate passcode key from the passcode, you need to run code on the device. You can't scale it by using multiple devices simultaneously. You couldn't use GPU because you don't know the exact process, exact key used by device when you go from passcode to passcode key. And speed for iPhone S about 6 passwords per second is not too much. And even 6 digits passcode couldn't be tested faster than in 24 hours. So it's very good in comparison with all other password keeper applications that we looked through during our presentation. And here is final summary table. Actually, there is a lot of statistical data, but the most significant is the last column. We measuring number of digits that consists the password that could be brute forced during 24 hours for some of password keepers. The less the number, the better protection. You could see that for most items, level of protection is about 12 to 14. So it means that you need to have at least 14 digits password to be not crackable in 24 hours. It's easy to convert to arbitrary character, not only digits. There are 95 characters on standard English keyboard, so it's about 100 of them. So you could just divide number in last column by 2 and get length of any character password that could be cracked in 24 hours. So for the keeper password and data vault, you need to divide 14 by 2. So 7 character password could be cracked in one day using one computer. So you could use a lot of them simultaneously if you have enough resources. And iOS passcode is not vulnerable for scaling, for GPU optimization, and even without optimization, it's much better than everything else. So it's a good idea to use passcode protection on iOS device and not invent something by yourself. And several conclusion words about the whole research. None of the tested password keepers offers something better than already offered by operating system. If you're using your password keeper on device that could be stolen or some password database could be extracted from the device, your data is vulnerable. And paid applications actually not necessarily better than free one. In our review, the best one is free one. And finally, kind of wish list for our users: always use passcode, and for iOS devices, use something more complex than standard 4-digit passcode, because until you have iPhone 4S, that's for now not vulnerable for boot level jailbreak. 4-digit passcode could be brute forced in less than 2 hours for any device prior to iPhone 4S. Don't connect your phones to untrusted computers, even to charger stations. There was kind of attack during one of DEF CONs when people were allowed to charge their devices, and during that some attempts of acquiring data through USB protocol was performed by charging station. And never jailbroke your iPhone by yourself because you make it vulnerable for a wide range of attacks. And recommendation for developers, you could see it on the slide. Actually, it's not too easy to implement good crypto without really understand how security works in deep details, but most people who develop password keepers, I believe they're very good programmers, but they need to study security and start their way from operating system, but not trying to invent anything else. And finally, we want to thank our partner from UK law enforcement agency, who initially asked us to check how it's hard to crack access to 1Password and Splash ID databases, because they have such database in some of their cases. So that was the initial punch for our research. We evaluate the 2 applications and find many interesting things and start going further, and now you can see the results. So thank you for your attention. If you have any questions, me and Andrei will try to answer them. And finally, please don't forget to complete your feedback survey forms. And again, thank you for your attention.